All right, let's take a look at example 1. It's labeled number 2 in your notes. All right, so we're supposed to track one point and basically sketch all three functions, okay? So over here I have a quadratic, otherwise known as a parabola, and it says track 1 point. So for this one, I will track 1 point. So the first one right here, right, for f of x, it should not be, overly taxing if I were to sketch f of x. Okay, let me actually draw the tick marks here. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. 4, 5, 6, 7, 8. Okay, so a parabola, right, f of x equals x squared. We know it's a U-shaped graph, right? It's going up. And by the way, if this value right here is a nice integer, in this case our a value is a nice integer, which it is, a is 1, you can go up 1 over 1, up 1 over 1, just for the first set of points. Okay, so there's my parabola. F of x is equal to x squared. We'll call that f of x. All right, and the point I'm going to track is, we'll keep track of this vertex right here, which is 0, 0. All right, now, this one right here, right, if I ask you, hey, how is this graph different from f of x? You would say reflection over the x, right, because there's a negative, and is shifted up 4 units, okay? So if I reflect it over the x, it's going to look upside down, but I go up 4 units. 1, 2, 3, 4. So the vertex, right, this point right here, we'll call it 0, 4, is at 0, 4. And then again, the a value right here is a nice integer. So I'm going to go down 1 over 1 to the right, down 1 over 1 to the left. This only works if it's an integer. And roughly there is going to be my, there's going to be my g of x, all right? All right, so there's f of x, there's g of x. The first two functions are not super difficult, right? But look at this one right here. How the heck do we deal with this one? By the way, vertex form of a parabola, if I haven't told you just yet, right? Here's a reminder. F of x is equal to a, x minus h squared plus k. H comma k is your vertex, all right? So vertex form is convenient because you are able to describe the transformation a lot easier because h shifts the graph left and right, k shifts the graph up and down, a changes the size of your graph vertically, all right? Okay, so what makes this problem tricky isn't the fact that it's in vertex form, right? The question should be, what is the vertex, right? Is it -2, +3, or is it +2, -3? And to answer that question, I'm going to do a little factoring here. I'm going to factor out the negative sign inside here, right? If I factor it out, it becomes this, right? There's my h of x, okay? And now, if I were to simplify this for you, right? Before I simplify this for you, how would you compare this to the parent function? What would you say? You would say vertical stretch, factor of 4, right? This negative right here means reflection over the y. I know it doesn't actually say compare, but this is good review. Y-axis, and then of course we know that the vertex is 2 to the right and it shifts the graph 3 units up. Okay, so this is just a quick summary of how is it different from the parent function f of x. So what do I do with that negative? Right, if there's a reflection across the y. So would you agree that if I give you something like this, right, -2 times 3 quantity squared, is that the same thing as 2 times 3 quantity squared? And you ask yourself, well, 2 times 3 is 6, 6 squared is 36, right? Well, -2 times 3 is -6, -6 squared is still 36. So this is true, right? So if that's true, what I could write as my h of x, okay, if I write it over here, is basically, this is just 4 times x minus 2 squared plus 3. Okay, so what you're graphing is this, and the vertex is going to be 2, 3. So 2, 3 somewhere over here, and I'm going to go up 4. Remember, this a value is a nice integer, so I'm going to go up 4 from 2, 3. 1, 2, 3, 4, right? And then over to the right 1. End up somewhere over here, up 4 over to the left 1. So your graph's going to look something like this. Okay, so there is my h of x. All right, moving on. Problem number 3. Let me copy this down from a quadratic function to an absolute value function. F of x is equal to the absolute value of x. And we have g of x is equal to the absolute value of negative x plus 3. And the last function we have right here is h of x is equal to 2 times the absolute value of x plus 2 minus 1. All right, so let's graph the absolute value of x first. Two, three, four, five, six. 1, 2, 3, 4, 5, 6. 4, 5, 6. 2, 3, 4, 5, 6. All right. So again, this is basically my parent function, right? The vertex is 0, 0. And just like for parabolas, right, this guy right here, this a value, which is 1, is basically your slope. So I'm going to go up 1 over 1, up 1 over 1, except this time the slope is going to be the same throughout because it's straight, it's not a parabola. Remember, for the parabola, using that a rise over run, it only works if it's an integer, and it only works for the first set of points, right? This one, you can keep going up 1 over 1 because it's a line, all right? So I'm going to label this as my f of x. And the point I'm going to track is the vertex 0, 0. All right, so just like your parabolas, right, there's also vertex form for an absolute value. Okay, so vertex form for absolute value function. It looks very, very similar. Okay, you're going to get f of x is equal to a, absolute value of x minus h plus k. H comma k is your vertex. All right, so if I ask you what is the vertex on g, okay, g is the tricky one. G of x is equal to the absolute value of negative x plus 3. The question is, what's the vertex? Is it negative 3, 0, or is it 3, 0? And the way you do that is just like I did on the previous example. I have to factor out the negative on the inside, okay? All right, now, if I say, hey, compare this to the parent function, what would you say? You would say reflection over the y and 3 units to the right, okay? And now you can say the vertex is 3, 0. Okay, now how do I simplify this? Just like the algebra in the previous example with the parabola with the negatives inside, would you agree that the absolute value of negative 3 is the same thing as the absolute value of 3? Just think about that for a second. And if you agree, right, what I can write for this particular function right here, I'm just going to write it over here, is basically forget about the absolute value, right? This negative right here, I don't need it. It's the same thing as this, all right? And the way I get that is by looking at this. The absolute value of negative 3 is the same thing as the absolute value of 3. Absolute value of negative 6 is the same thing as absolute value of 6, right? So I don't really need this negative right here. So this is what I'm plotting. The vertex is just 3, 0, right? H comma k. So 3, 0 is right here. I'm going to go up 1 over 1, up 1 over 1, and there's my V-shaped graph for g of x. Okay, there's my g of x. All right, last but not least, we have to graph h of x, which is 2 times absolute value of x plus 2 minus 1. Okay, so this vertex right here, right, would just be, your h comma k would just be negative 2, negative 1, okay? Again, how is this different from the parent function? You shifted 2 to the left, 1 down, and then it's a vertical stretch by a factor of 2, okay? So it doesn't actually ask you to compare, but I'm just comparing with you anyways. So vertex of negative 2, negative 1, negative 2, negative 1 right here. I'm going to go up 2, 1, 2, over to the right 1, up 2, over to the left 1. And there is my h of x. Okay, so I'll just label it. This is my h of x. Why are you going up 2 over 1? Because remember, this a right here is basically your slope. And of course, it changes the size of your graph.